Hey everyone, and welcome. Today we're going to pull back the curtain on software testing. It's that critical process that stands between a brilliant idea and a totally frustrating app, making sure the tech we rely on every single day actually works the way it's supposed to. And let me tell you, the stakes couldn't be higher. This isn't just about your phone freezing up. As this really chilling example shows, when software fails, it can have absolutely catastrophic consequences in the real world. This is exactly why a smart, structured approach to testing isn't just a nice to have. It's essential. So, here's our game plan. We'll kick things off with why this stuff is so important. Then we'll get into the basic rules. After that, we'll dive into the big strategies, static versus dynamic testing, and we'll wrap it all up with the key things you need to remember. First up, why does testing matter so much? Well, before you can even start finding problems, you kind of need to understand how they happen in the first place. And it all follows a pretty clear chain of events. At its heart, software testing is really about two things. First, making sure we build the product right, that the code is solid. And second, making sure we're building the right product, that it actually does what the customer needs it to do. The goal is pretty simple. Find the bugs before your users do. Okay, so this is where it gets really interesting. A problem doesn't just appear out of nowhere. It all starts with an error. That's just a simple human mistake. Let's say a developer misreads a requirement and thinks a password needs to be 6 characters long when it should be 8. That human error leads to a fault, which is the bad code they write. The bug is now in the system, but it's hiding. The problem only becomes visible when it causes a failure. That's the moment a user tries to create a 6-character password and the system wrongly accepts it. The whole point of testing is to catch that fault before it ever has a chance to become a failure. Okay, so we know what a software bug is and how it's born. So how do we actually build a process to find them? Professional testing isn't just randomly clicking around hoping something breaks. It's a disciplined game with really clear rules, definite starting points, and, of course, finish lines. And the fundamental building block for all of this is the test case. The best way to think about it is like a recipe. Seriously. It tells you the exact inputs or ingredients to use, it gives you the step-by-step instructions, and it tells you what the expected result, the finished dish, is supposed to look like. This is what makes testing something you can repeat, and not just a one-off thing. So, how do we know when it's time to start testing? And, maybe even more important, how do we know when we're done? Well, that's where entry and exit criteria come in. Entry criteria are basically your green light. They say, yep, the code's ready, the requirements are signed off, the test environment is good to go. Let's do this. And exit criteria? That's the finish line. It tells you when you can stop, like when every test case has been run and all the show-stopping bugs have been fixed. Okay, now we're at our first major fork in the road when it comes to testing strategy. The big question is, do we want to check the blueprints of the car, or do we actually want to take it for a test drive? That's the fundamental difference between static and dynamic testing. This table breaks it down perfectly. Static testing, over on the left, is like proofreading a book. You're reviewing the code and the documents without actually running the program. The huge win here is that you can catch mistakes super early, and believe me, that is always cheaper. Now, dynamic testing on the right, that's the test drive. You're actually running the software. This is the only way you can find those tricky bugs that only show up when the program's running, what we call runtime errors, and really confirm that it works in the real world. All right. Time to pop the hood and take a look at the engine. This is where we get into the world of white box testing, where we care a lot about how this software works on the inside. So, for white box testing, the tester absolutely needs to have programming skills. They get the source code, they see the diagrams, their entire goal is to examine the internal logic, to follow the different paths the code can take, and make sure every little piece is doing exactly what it was designed to do. And to do this, testers have a few key techniques. Inspections are these really formal, structured reviews to hunt down defects. Walkthroughs are a little more casual. It's where the developer kind of presents their code to the team and explains their logic. Code coverage is a massive one. It's a metric that tells you exactly how much of your code your tests have actually run. I mean, think about it. If a line of code has never been executed, you have zero idea if it works or not. And finally, they analyze code complexity to find parts of the software that are just so tangled up that they're practically guaranteed to be hiding bugs. The goal here is to leave no stone or no line of code unturned. Okay, let's slam the hood closed. From a user's point of view, who cares about the engine? They just want to know one thing. Does the car drive? This is the whole idea behind black box testing. With black box testing, the software is literally a mystery box. We don't know how it's coded, and frankly, we don't care. We are only focused on one thing. If I put this specific input in, do I get the expected output back? It is all about testing against the requirements, looking at it completely from the outside.
So how do we actually do this in a smart way without having to test every single possible number in the universe? Let's take a super simple example. You've got a field that says you have to be 18 or older. Where would you even begin to test that?
The first really clever strategy is called equivalence partitioning, and this is just brilliant. Instead of testing every possible age, you just divide all the possibilities into logical groups, or partitions, that should all behave the same way. So for our example, there are really only two groups: invalid ages, anything under 18, and valid ages, 18 and up. Now you just have to test one number from each group, say 12 and 25, and you can be pretty confident about the whole group. You've just taken millions of potential tests and boiled them down to two. That's efficiency. But wait, there's another powerful strategy, and it's called boundary value analysis. This one comes from pure experience. After decades of testing, we know for a fact that most bugs love to hide right at the edges, or the boundaries, of these groups. So you focus your energy right there. For our age requirement, you'd test 17, the last invalid number, 18, the very first valid one, and 19, the next valid one. This is an incredibly effective way to catch those super common off-by-one errors that developers make all the time. All right, let's bring it all home and tie everything together. We're going to summarize the most important things you need to remember from our little journey into software testing. Probably the biggest takeaway is the difference between these two main approaches. Just remember, white box testing is the mechanic's view. You're looking inside the engine to find hidden flaws, and for that, you need programming skills. Black box testing is the driver's view. You're just checking if the car works from the outside, based on the user manual, and you don't need any technical knowledge at all. And let's revisit that chain of failure one last time, because it is so, so important. It all starts with a human error, a simple misunderstanding. That creates a fault, which is the actual bug sitting in the code. And if that fault isn't caught by a tester, it's going to cause a failure for an end user. The entire job of a tester is to find that fault before it ever gets the chance to become a failure.
So what now? Well, the absolute best way to really understand this stuff is to think like a tester. Take a simple sign-up form on any website. What are the rules for the password? Does it need a certain length? What are the boundaries you should be testing? Applying these concepts for yourself is the fastest way to go from just knowing about testing to truly getting it.